Hello everyone. In this video, I'm going to show you how to graph the log function. The first thing is we're going to look at the general form. So let's take a look here. We have f of x is equal to log base x minus h. So the h, as we have seen in other functions, will determine the horizontal shift left and right. And the k right here will determine up or down. So let's look at the function we want to graph. We have f of x is equal to log base 3 x minus 1 minus 2. So in parentheses, the x minus 1, our h right here is 1. So that means the graph will shift 1 to the right. And then our k value here is -2, which means the graph will shift 2 down. So the first thing we want to do is identify the parent function. And if you remember, I mentioned the parent function is always going to be the graph without the shift. In other words, without the -1 and -2. So the parent function is just f of x is equal to log base 3 of x. So I'm going to go ahead and write that down right here. So p of x is equal to log base 3 of x. That is the parent function. Now, in order to graph the parent function, the easiest way to do that is to write the parent function in exponential form. And we have already learned how to switch forms. So the first thing we want to ask, what is the base? The base here is 3, so we're going to write 3. The exponent is always what the log equals to. So in this case, it equals to p of x, which happens to be the same thing as y. So 3 to the y is equal to x. Once we have switched it to exponential form, we can now make a table and complete the values. So our inputs are going to be the y values right here. We're going to input for y. All right, so what happens when we say 3 to the -2? Well, 3 to the -2, if we remember working with negative exponents, is the same as 1 over 3 squared, which is the same as 1 over 9. So when y is -2, x is 1/9. And 3 to the -1 is the same as 1/3, or 1 over 3. So when y is -1, we have 1/3 for x. And then if we input 0 for y, 3 to the 0 is the same as 1. So when y is 0, x is 1. And if we continue that, 3 to the 1 is just 3, and 3 squared is 9. Once we have a table of values, we can graph the parent function. So we're going to go ahead and graph that. So when y is -2, x is 1/9, so that is really close to 0. I'm going to put a point here. When y is -1, x is 1/3, that's about 0.33, so it's going to be about here. When x is 1, y is 0, that's going to be a point right here. And when x is 3, y is 1, we have a point here. And when x is 9, y is 2. So if you remember the log function, as we mentioned, it is a curve that looks like this. It's going through all these points. It's going to increase as we go to the right. So draw it the best way you can. It is a sketch. So I have the graph forever going to the right and going down this way. This here is the parent function, p of x. But we don't want to graph the parent function right now. What we want to graph is the function I highlighted. We want to graph the function, this whole function here. So we have already mentioned that this graph shifts 1 to the right and 2 down. So if we look at the function, how does it shift? It shifts, the graph shifts 1 right and 2 down. So all we need to do to graph this is to take every point from the parent and shift it 1 right and 2 down. So for example, if I take every point that we have graphed here and move it, then we will graph the function. So we're going to take every point I highlighted here, move 1 right and 2 down. So for example, let's move this point 1 right. So 1 right and 2 down will be right here. And this point I'm going to move 1 right and 2 down. That will be right here. And this point I'm going to move 1 right and 2 down. That will be right here. And I'm going to do this point right here, which happens to be a fraction. So I'm just going to move 1 over and 2 down. So it'll be a little bit over the line here. And I will move this 1 over and 2 down, and it kind of is off the graph. All right, now another important thing that we need to look at is a vertical asymptote. So what is the equation of the function's asymptote? Well, that is always going to be when we have x minus h is equal to 0. Our vertical asymptote is always going to be the line at x equals h. So if we just add h on both sides, we will have x equals h as our vertical asymptote. Now, why that is because, as I have mentioned before, the value of the log can never be negative, nor can it be 0. So x minus 1 is our equals to 0 is going to be our vertical asymptote. So I'm going to take this whole x minus 1, and if we set that equal to 0, then we see we have an asymptote that is a vertical asymptote at x equals 1. So I'm going to go ahead and draw that asymptote at x equals 1 right here. And then I'm going to draw my graph. So my graph that shifted 1 right and 2 down is this blue graph I'm drawing to the best of my ability right now. This right here is f of x. Okay? Now, answering the questions, what is the domain of f of x? Well, remember, domain is always the x values, and we can look at the graph or we can look at the equation. So remember, I said that this whole value here, x minus 1, cannot be negative, nor can it be 0. So if we wrote that x minus 1 has to be greater than 0, because greater than 0 just means positive, and of course it can't equal 0 either, so this is why I have a greater than symbol. So if we add 1 to both sides, our domain is just going to be x is greater than 1. And if you look at the graph, you can see that the blue graph is greater than 1 for x. So I'm going to go ahead and say that domain is x is greater than 1. And we already said that the asymptote is x is equal to 1. So the asymptote is where the graph approaches but will never touch. Okay? Now the last thing we're going to look at is the range. If you look at the graph, and even if you look at the table, the range right here shows you could see the range, that I could have negative and positive values pretty much input in. We can go on forever, so I could keep inputting values either to the negative or positive side. So that indicates that the range is all possible numbers, which we will say all real numbers. Now, if you look at the graph continuously goes downwards forever, and it also goes upwards forever. So there's no restriction on the range. So we will say for the range that we have all real numbers. So all real numbers for the range. And this is how we can graph the log function.